Hello there. This
Hi.
is Fick and Damien.
This is our 3 resistor circuit that we did for lab.
It's the video.
Okay, this is our theory for the first circuit. It's 3 resistors in series, and we did the calculations. V equals IR, our voltage using 12 volts and 3 kilo ohms equals 4 millivolts. And the voltage over on the side should drop 4 volts after each resistor, thus equaling 0 going back to the ground.
We then plugged our circuit into LT Spice to simulate our experiment, and we determined that with a current or a voltage supply of 12 volts, that each resistor will have 4 amps of current at each one.
Okay, so this is our actual experiment with 12 volts that we measured. Next is our 4 amps across one resistor, and the final 4 amps, milliamps across another.
Our second theory and our second circuit in this experiment was a circuit involving 3 resistors, 2 of them being in series, the third one in parallel, and this is to prove that if you have 12 volts going through a circuit, that you'll have 12 milliamps going through that third resistor and then 6 milliamps going through the remaining 2, with that making a total of 18 milliamps going through the entire circuit.
Okay, and this is our LT Spice simulation showing that our theory should work in this circuit.
To start this circuit off, we initially covered our butts by making sure we did indeed have 12 volts going through it. We then moved on to show that our 2 resistors that were in series had a total of 6 milliamps flowing through each of them, and then as a correction, we did not take a picture of the one that was in parallel, which should have 12 milliamps flowing through it.
Okay, this is our last circuit that we did. This is 3 resistors in parallel. As you can see, we have in our theory 12 volts and a total of 36 milliamps running through the entire circuit.
As previously established by our other 2 circuits, we then again plugged this theory into LT Spice just to confirm that it will work on the experimental level.
And lastly, just to make sure we had 12 volts to check that, and then 36 milliamps throughout the entire circuit, and then another 36 because it's in parallel.